Okay, so we're changing to quadratics now, moving up the ladder. It's really hard for me to try to figure out where to start this discussion. I'm assuming, and I think falsely assuming, that there aren't any gaps from the Algebra 1 experience. Multiplying factors and solving quadratics with the quadratic formula. A whole host of topics that I don't know the audience I'm speaking to right now in terms of skill level. But I think I'm going to start with pure mechanics of how to write the equation of a quadratic given a vertex and another random point. This one isn't random. I picked a canned situation here to highlight something, but change these all you want. Teach you how to write this equation in 10 seconds or less with practice. Another 10 seconds to write the roots and another 10 seconds to write the range. Well, I think that's like a 3-second question. Okay, but like anything else, we got to start the discussion. It's got to start somewhere. All right, so we were practicing putting linear functions in the ax minus h to the first power plus k form. And I didn't hold my discipline. I kept forgetting to write the 1 there in those videos, and I wish I hadn't. But, you know, linear function, 1 dimension. Now we're looking at a 2-dimensional picture. Quadratics, fancy word for 4, you know. You think the quad in a campus quad, you know, 4 sides to it, and Latin for 4. And rectangles really form the basis, I think, of this algebraic study. So much of it is based on rectangular relationships all the way through calculus. So where to begin? Well, if you're going to write an equation quickly, I guess you got to look at this and say, well, where does this pattern start from? And I hope you know, your eyes are zeroing in on the coordinate 5, 7. And so no different than a linear function, we write x minus, I didn't need to do that, x minus 5 plus 7. Well, the same thing happens here, x minus 5 plus 7. And I'm sure I've got a lecture out there somewhere about the geometry of change in the quadratic. If not, I'll have to make one so that I highlight just the most important aspects of rectangular change. In this case, squaring change. And so what do you do when you write the equation of a line? You look at the linear change from 5 to 11 is 6. Okay, well, that's 6 units of change linearly, but in terms of quadratic, it's 36. And so what did you do with a linear change? You divided it out of the problem. Right? Divided it out of the problem, and you said, well, how do you get from 7 to 79? Well, 72 units of change. Okay, well, what is it in the quadratic? It's still 6 units, but you're squaring them. That's why I have over here the operational change ratio. All right, because 36 units doesn't take you from 7 to 79. So you get rid of that. You get rid of that 36 units. What does take you from 7 to 79? 72. And we can now see that we have a factor of a coefficient of 2. 72 divided, that's why I say it was canned. Okay, so when you put 11 in, 11 minus 5, 6. 6 squared, 36 times 2, 72 plus 7, boom, bingo. It goes through that point. And this is a minimum. And when do you get a minimum area? When do you have no area? When you have no side length. Right? And so therefore the 5 is acting like a, 5 minus 5 is acting like that minimum area. Because it doesn't matter whether you have positives or negatives. When you square them, you get positives. So everything's going up. All right, so that's our first discussion. That gets the discussion started. And so the A term, to put it into familiar terms, is rise over run squared as measured from the vertex. Rise over run squared. It's just a principle of conversion, subtraction and division. Well, what are we dividing? The operational change. And that holds true for higher polynomials. Again, they get a little more complicated. But that pattern basically continues for higher polynomials as well. I'm running out of ink here. That's too bad. Let me find a marker that you can see easily. I think green. I think that'll show up on the video. Yeah, so we'll go with that. All right, now what are the roots? All right, I'm not even going to write this. I'm not even going to look at that. I'm just going to look at this and go. And we haven't really even talked about imaginaries, but I'm just going to write it anyway. So the roots are based from 5. I'm moving to the left and right, but instead of going up, I'm pretending I'm coming down. How far do I have to come down? 7 units. I got to come down 7 units to get to 0, but I'm multiplying by 2. That 2 used to be there, right? And so therefore, I'm going to write I there. And just to show you, you don't know how to do that yet. You probably don't even know what I'm talking about, but the conversation has started. All right, and the range of this are y values greater than or equal to 7. Right? There's the 3 things that you need to do. Now, I will do the inverse operations here. Just to show you, x minus 5 squared plus 7 equals 0. So, okay, so you take 7 away, bang, you divide by 2, bang. You undo squaring, which is plus minus square rootings. Later in the course, I'll tell you why we write I there. And minus 5 becomes positive. All right, piece of cake. And we're going to learn how to multiply these out, do the quadratic formula, complete the square. All of that stuff is going to happen with, you know, the typical practice every day. All right, so let's practice 4 problems here, just the mechanics of getting these equations. That's all we'll do right now. Just do the mechanics. And it doesn't hurt to do the, let's make this, so you get a real answer here. Let's make this minus 2. All right, so how do we write this? We write the vertex. So we use subtraction to get rid of this, to minimize our area, smallest area, and we want minus 2. We've been doing that with the equational line. The only thing that's changed is we're squaring. We're squaring our change, and our change is 10 units. If we square it, we get 100 units of change. 100 minus 2 is not 11. Sorry, folks, 100 minus 2 is not 11. Get rid of that 100 units, minus 2 to 11 is 13. That's that equation. Now, if I want to set it to 0 to find my roots, then I'm measuring from -3. I'm going to the, that's the axis of symmetry. I'm going to the right, which is a plus. I'm going to the left, which is a minus. I'm undoing the squaring process. I've got to go up 2 units. And this is an awkward one. And I got to divide by that multiplier. So that wasn't awkward. Okay, but that's the thought process. Okay. We won't do the roots anymore. I mean, I think that's just going to be for something we do in the future. We're just going to practice 3 more of these. Get the equations. The operational change. Dividing out the operational change. All right, I like this one. This is my kick the ball up in the air problem. Gets us to look at initial force and gravity, but just the mechanics. All right, there's the vertex. That's where the pattern emanates from. X minus 2 squared plus 67. Highlighting the vertex. If I go back 2 units and square, I should go up 4. Folks, that didn't happen. Get rid of it. What did happen? You went from 67 to 3, which is minus 64. Now, a look into the future. If I multiply this out, I get minus 16x squared plus 64x plus 3. Okay? Minus b over 2a, we're going to be talking about in great detail. Minus 64 over 2 times this is minus 32. Lo and behold, that's a quick way of finding the x value of a vertex. I haven't explained why. That'll come in the future. All right. So that would have become this statement. And if I plug 2 in, that's 128. That's minus 64. Might as well start the conversation. A 2-to-1 ratio that always happens at the vertex. If I add these together, I get 64 plus 3 is 67. That's an easy way to find the y value. And I've already got the x given. It's minus 16. And that's the graphing form. That's the graphing form for a quadratic. Okay, let's go and do two more. And, you know, this is day one. Your brain is trying to process something. You're gonna have to just let it settle. Just gonna have to put a smile on your face and go, oh, there's something going on here. All right, so 1 negative 12, x minus 1 squared minus 12 gets us started. Okay, how do you get from 12 to 29, minus 12 to 29? Looks like you're going up 41 units. Then from 1 to 5 is a change of 4. I should have gone up 16. Should have gone up 16 units, but I really went up 41. And that's the ratio of change in this quadratic. All right, so there's not a single graph at the high school level that I don't think you can, takes more than 10 seconds to write the equation of exponential, log, sinusoids. Maybe the cubic takes 30 seconds, but most of them are quick and easy. So what do we want? We want, how about a minus b? A gets us b. Let's get a gets us b and c gets us d, and let's get a little formula. Let's do it from the positive side, might be easier for you to see. So let's go a to b, c to d. All right, so we got to get rid of a, minimize the square area. We want b for an amount. How do we get from d to d? Oh, that's d minus b. Yep, you get rid of the b's, you bring d in, provided you cancel this. How do you cancel this? C minus a squared. For those of you who like a little bit of formulaic action. All right, but let's go back and do another one with the numbers. You can freeze the video, screenshot anything you want. 4 negative 7. Let's go. Maybe I'll give you a nice one here, and then we can look at the roots one last time because it's reps. It's all about reps. We're going to do this 5 days in a row. All right, and we're probably, I don't know, I got about 12, 15, 16. I'm looking at 16 problems over there. So two sets of 8 and this, and we'll get a lot of the fundamentals in front of us so that we can practice them the whole semester. All right, 4 negative 7. Let's go over 5 units and let's square. We should go up 25, but let's go up 50. Let's go up 50 instead, which is doubling the squaring process. All right, and if I go up 50, I believe I'm at 43. And if I go over 5, I believe I'm at 9, 43. I did some quick mental math there. I hope I did that right. I think I did. So we've got x minus 4 squared minus 7, highlighting the vertex. All right, the pattern emanates from there. And I don't want that 25 units of change because I'm trying to get to 43 from negative 7. I've got to go up 50 units. All right, so see if you can look at this now and see the roots. The roots are here at a height of 0. Not 43, not negative 7, a height of 0. So what are my x values? You know, that probably 0 is much lower. So my x values are probably pretty close to 3 and maybe 5, 3 and 5 maybe. But let's find out. Let's find out what they are. So how do I get from negative 7 to 0? Got to go up 7 units. Where the heck am I? Oh, I'm multiplying by 2, so I got to divide by 2. I'm undoing the squaring process, so I got a plus minus square root, and I'm measuring from 4. All right, so what's 7 divided by 2? You know, it's you know, near 4. The square root of 4 is near 2. So 4 plus 2 is 6 and 3. You know, I was talking 3 and 4. It's more like 2 and 5, closer to that. But now let's actually look at our answers and see how this produces a 0. Okay, so I'm going to have to make some space to put my answers in here. All right, so let's move the minus 4 over here. How about if I write 4 instead of 2? Let's square, subtract 7. Now let's see how this works. 4, and let's say 50 over 25 is 2. Just the mechanics, though. Just working with some mechanics, which you should be able to follow. All right. Well, why is subtracting 4 from 4 nice? Because it gets rid of it. What happens when you square a square root? What happens when you square a plus or a minus? You get a plus. All right, so we don't have to write the plus. What happens when you square a square root? It undoes it. what happens when you divide by two and multiply it by two inverse operations. And what's 7 minus 7? Bingo, 0. All right, so this is the kind of stuff we're gonna start exploring, the squaring process. And what can the squaring process do? It can write an equation of height to time. You know, you give me the maximum height here, the time I started, the location the pen was at, and in 10 seconds, you got the equation. Yep, let's drop an apple on Newton and go from there. All right, so that's just to get the conversation started.